can start with your presentation.
Okay, thank you so much. So, first of all, thanks for inviting me. My name is Filograna. I'm the senior researcher and project manager at Engineering Informatica, an Italian digital transformation company. And the group I belong to is focused on the innovation through the research and innovation department that comprises more or less 400 researchers and data scientists. And our research is focused on innovation for public administration, digital experience, and in particular the adoption of disruptive technology in different fields of innovation and research in our life, such as social innovation, smart cities, smart governments, and natural disasters management. And we have expertise in big data analytics and visualization, cloud infrastructure, open data management, and system integration and interoperability. What we will see during this session in 1 hour, more or less, we will talk about the data storytelling and big data value chain in natural disasters management. So we start on what story the data tell us and how we can transform raw data into business information, how to take advantages from this business information in order to support the first responder on one end and making the citizen more resilient. So we can go ahead and start with conversation. So I don't know if you know who is this lady. This lady is Florence Nightingale. Was a nurse during the Crimean War in 1856. But why we are talking about her? Because she was the first storyteller. So in the 1956, Florence Nightingale came back home from the Crimean War. And after being the responsible of the wide network of different UK infirmaries in the country, and she understood from her experience that the causes of mortality in the ranks of the army were not only due to the guns, to the bullets, to fighting with the enemy, to the cannons, but also to the healthcare condition in which the soldier lived. And she collected a lot of data, analyzing them with the support of statistical scientists, and the result of their analysis demonstrated that one of the most important factors of the death in the ranks was among the patients that were hospitalized were the overcrowding of the hospital. So starting from this raw data and result, she and her team proposed some solution. And the solution were to improve the sewerage network reclamation, to clean the air in the rooms, and to reduce the overcrowding. And she presented this data to the politician, to the member of parliament and doctors, and but her first objective was the chief of the British Army, that was the Queen Victoria. And in order to catch the attention to the politician, to the policymaker in general, she couldn't present the raw data as they are. So she adopted, for that period, let me say, a fascinating approach to introduce information coming from the data analysis. And Nightingale chose the use of the hand-drawn diagrams, as you can see in the right part of the images, that never seen before, going beyond of the visualization of the graph themselves and getting a real data storytelling. So after this discussion, after presenting this new data in this new way, she was able to introduce and to demonstrate what was their thought. And these reforms were included in the British Public Act in the 1875, having, of course, a huge impact not only for the army, but also for the citizen healthcare condition, as you can imagine. But we are talking about analyzing data, a lot of data. And nowadays we talk about big data since 10 years ago, more or less, no? But who managed big data for the first time? And for the first time, we talked about big data, or we heard, or someone started collecting big data was the 1899, where the physician and in the domain of particle physics, the big data growing and start to be used. The first one was in the cloud chamber, that is a particle detector using for visualizing the passage of the Ionian radiation. At the beginning, they used this to discover the cosmic ray, and they collect a few events per cycle, but the data was wide. Then we have in the 1962 in the Standard University, the Standard Linear Accelerator Center that reached an energy of 15 gigaelectron volt, and they collected data of 100 terabytes per year. Then we have all of us knows the LHC, the Large Hadron Collider, that collects data around 1-2 petabytes per day. In 2012, they could discover the Higgs boson. And going to the evolution of the data, we can see that the LAC accelerator collect 300 terabytes per year, and here we will see that until 2023, the LHC collect 1,000 petabytes. So we start from a terabyte and goes to the petabyte. But what is the difference between the big data, past big data collected by the physician during the experiment and the new way of big data? So now we have what is the real problem today? No, is the difference of data sources. So we can develop application aggregating data from different domains, not only from just one domain. And it is the difficulties because each domain speaks its language, and data can be different, not only from different sources, but also different among them. And for example, now we have the big data application in healthcare. So the level of the data generated within healthcare system is not trivial. So traditionally, the healthcare industry lags in using big data because of limited capacity to standardize them and consolidate. So the data was not interoperable. But now we are improving also the healthcare sector by providing personalized medicine and prescriptive analysis. So with this added adoption of the e-health and also the wearable technologies that we can use also during our when we run, for example, the volume of data is increasing, and also the volume of the analytics that we can do with this data. And by mapping healthcare data with geographical data set, it is possible to predict disease that will escalate in specific areas, and based on this prediction, it is easy to strategize the diagnostic and the plan for stocking, for example, serums or vaccine. Another example of the use of the big data is the McDonald's, for example, no? Because big data is not just used to tailor our customer experience, but they use big data, McDonald's use big data in order to shape the key aspect of their offering offline too. So not only online data, but also offline data. So the analysis of big data can be used also offline. And these include, for example, when we buy our hamburger through the mobile app or through the drive-through experience or digital menu, no? In the stores, and with its own app, McDonald's collect a lot of information on our habits, so our preference, and this lets them, in order to offer a tailored rewards to encourage repeat business. They offer the offers, for example, in specific period of the year, so in specific period of when the events occur. But they also collect data from each restaurant driving through, allowing them to ensure enough staff when in order to cover the demand, for example, during the evening instead of during the morning, or during some specific events, for example, Halloween, New Year's Day, and so on. And their digital menu offer different options depending on factors such as the time of the day, if any events are taking place nearby, and also even the weather condition, because if it is a hot day, we don't expect it to be offered a spicy burger, but we prefer, for example, McFlurry or cold drink, and they gave some offer on that. So, but Now we can take big data in natural disasters management. As the professor Cyrus, that is the secretary of the World Meteorological Organization, says that the number of weather, climate, and water extreme are increasing and will become more frequent and severe in many parts of the world as a result of climate change. We can say that we have, due to the analysis of big data, we have two information. While the number of the disaster has increased by a factor of 5, according to the WMO, the deaths from disasters have decreased by a factor of 3. And this is due to the preliminary warning, early warning, and improving of the disaster management in prevent, manage the disaster when it occurs, and also assess the damages after the disaster. And how the big data can help in emergency situation. And here we have some example in disaster management, where the big data technologies are an important aspect to tackle the disasters management and make emergency response very efficient. For example, in the crisis mapping, in Nairobi, an open source platform of software to gather information was developed in 2008, and this technology works on analyzing the areas that became violent after the Kenyan presidential election. So information at that particular time came through the social media, and through the analysis of these social media, there are a lot of eyewitness, and the same information was put on Google Map that was interactive, helping the residents get cleared of danger. And the same technology was used again in the 2010, where during the Haiti floods, earthquake, and this saving a lot of life of the citizens who were in that region. For example, another way is to bringing a loved one and family closer. In this case, Facebook and Google developed services to stay connected with your family during a disaster, a natural disaster. And huge online systems have been deployed by them that enable the member of family to stay connected during and after the separation in times of emergency. And a sort of person finder application by Google was released after the Haiti earthquake for helping people to be connected among their family members. And finally, another example of how to use the big data in disaster management is to prepare for emergency situation. So not only during the event, after the event, but we can define the right policy by using the evidence-based approach. And for example, citizens share information that can be life-saving, such as, for example, the presence of family members that have a physical problem inside the household. And in this way, the decision maker and the planners can plan an evacuation plan, for example, or define a better evacuation plan according to the evidence-based approach. So, but what is the approach in the big data and data storytelling? The primary goal of the data analysis is to produce the meaningful insight from data that provide additional business information because the raw data itself are not an added value. So what is important is the information that can be understood by the first responder, for example, the politician, the policymaker, and decision maker, and the planner. So what is the flow of information, or what is the approach that we need to follow? So first of all, we need to understand what is the problem, and collecting the user needs. Because we have to provide the policymaker and citizen with information to face with the disaster. Then we create a data catalog, so a collection of user needs by using the storytelling methods, and starting collecting this data. We can create a data catalog where all the data can be stored and reused. But the data coming also not only from the, for example, open data, or from the weather station, or from whatever user information we can extract on the digital sensor or the digital device. The data coming also from the co-creation activities organized with the civil society, with the communities, and all this information it's important to be collected in and merged among them in order to implement the algorithms needed to analyze all those data. And finally, we can start from the result of this algorithm in order to visualize in the dashboard the data, in this case the business information, that can be an advantage for the policymaker and the first responder in order to take decision. So, as the first president of Italy, Luigi Einaudi, said, we need to learn, discuss, and then decide. Why co-creation? Because we need to break the gap between the technical people, the developers, and the decision maker. So, and also because sitting all around the table, we can discuss and we can speak the same language. And the co-creation section enable to speak the same language. And the co-creation are also the mean to collect data that is not already digital, no, from the discussion. And the discussion is important in order to understand the needs of the user. And we need also to be in line with what the European Commission promotes in these last years. So to have the data should be fair, no? The fair principle. So findable, accessible, interoperable, reusable. But let me say also available and usable. So starting from the first, this acronym, no, the fair data, we need to be to create to have data findable. So in order to have a clear description of data, accessible, who can use this data, interoperable, using data models in order to speak the same language, and reusable, because this gives value to data by exploiting their metadata description this kind of property, the reuse of the data, can allow also different stakeholders, for example, cities, small and medium enterprise startups, to reuse this data and to make business around this data. But another important aspect of the big data is the data availability versus usability. The data availability refers to the accessibility and availability of the data to the user. That means that having data stored in a system that can be easily accessible, and we can retrieve data whenever we need. This requires proper infrastructure, so the data availability is in line with infrastructures such as storage system, network, and software. So in order to ensure the data is readable, available. On the other hand, we have the usability that refers on how easily the data can be understood, interpreted, and analyzed by the user. This is more in line of the real data itself, no? Instead of the data availability that is most on the software infrastructure. And the usability involves presenting data in a meaningful and user-friendly, we are talking about storytelling, no? User-friendly format, so we can derive insight and make informed decision, so evidence-based decision. And the data usability also requires that the data are clean, so the data cleaning, transforming, harmonization of the data, and visualization of the data in order to make it more comprehensible. So data availability and data usability, of course, are closely related, but they are two different and distinct concepts. So while data availability focuses on making data accessible, as we said before, in terms of software and infrastructure, data usability concerns itself with making data useful and meaningful for the user. So data availability alone does not guarantee effective use of data if it is not present in a usable way. So important to have both in order to have a wide and an effective analysis of big data. And here you can see some association in Europe that drives the standard around the data. They support, for example, several data models, data format, and in the last 5 years, we are talking in the community of data in Europe about the data spaces. Sorry. So, starting from what we saw at the beginning of this presentation, the storytelling and the visualization provided by Florence Nightingale, here we can see the real importance of the use of the dashboard, that is the visualization, the new storytelling about around the data. So with the visualization and having this dashboard interactive is a way to be user-friendly, and this led to take more informed decisions. And the data representation is the union between the analytics of big data and the storytelling with data. So as the headers naming say, without data, you are just another person with an option. We need to base our thought, our decision on data. And in the domain of disaster management, the cycle of the analysis of big data comprise four different phases, which are mitigation, preparedness, responses, and recovery. And we have different goals for each phase. As you can imagine, the goal of mitigation phase is to minimize the effect of the disaster. The main focus of preparedness is to respond to a disaster with a plan. The response activities, for example, are due to provide the required disaster management services to save life during the disaster, and the recovery is to assess the damage and come back to a normal. What the technologies in the big data in the disaster management? So when the disaster happens, rescues can use real-time satellite imageries to see what's happening on the ground and find people and vehicles, for example, during the disaster. Meteorologists can use satellite image in order to spot the disasters as they are forming, and if they see early sign of, for example, a tropical storm, of the plumes of smoke from an active volcano, they can use this preliminary information in order to evacuate people. And we can also use artificial intelligence that can help make sense of views from the space. So we have a lot of information and technologies that we can use during the disaster. And for example, in the 2005, during the Hurricane Katrina that devastated the Louisiana and Mississippi, they used the drone in order to search for people, and after just 2 hours they rescue people, and they determined there are no one was trapped. And the drones can be equipped with sensor, with some meteorological station, in order to provide data from directly in real time from the field. And then we have also the social media, because during the disaster, we can exploit a lot of information that we as citizens can provide during the disaster through the social media. And there are technologies that can analyze this kind of information and provide usable information to the decision maker. But also, while drones and tweets can provide critical information during and after a disaster, the Internet of Things, that means sensor installed in the field, can provide critical information before the disaster. So, for example, the water level monitoring sensor can catch early signals of floodings in the rivers, monitoring so the height of the waves. And some sensors, for example, can measure the air quality to detect dangerous level of pollution or chemicals like smoke or radiation. And this can be used in order to prevent some kind of events. But clouds are often messengers of catastrophe. Satellites, drones, social media, and IoT, however, are using cloud computing, not clouds itself, to capitalize on big data and advance the world of disasters management. And instead of jeopardizing lives, this kind of cloud is actually save them. So the use of cloud computing allow to capture, to manage, to storage all the data that can be captured in the edge and quickly processed in the cloud. What could be the weak point of this approach? The weak point could be the delay in transition of the data, and the strange point is that we can compute, we have more computational resources. And is a brief introduction of, but I skip this slide because Lorenzo in the previous presentation already introduced the TEMA project. I would like just to see that TEMA is an AI-enabled natural disasters management platform with the goal to be to support the end user, in this case, first responder, civil protection, fight fire, in order to take advantages from raw data, transform it in business information, in order to be visualized in the TEMA platform, in the TEMA technical solution, that and this kind of visualization are interactive, intuitive, and accessible to all the users. I'd like to spend some words about where we tested our solution dealing with the analysis of big data in order to produce relevant information to fight the floods and the fire in the Europe. So we test this. We are testing because the project is ongoing, and we are testing our solution in 4 pilots in 4 regions in Europe, in Germany, Bavaria. We deal with floods as well as in Greece, in the municipality of Matouny. And we are testing also the prevention and the management of the wildfire and forest fire in Italy, in Sardinia, and in Finland, in Cagliari, in the Canyon area. What is the concept of TEMA? So we have a lot of data sources. So we are able to collect data from sensors in the field, from satellite, and from drones, smart sensor, and social media. This data is used to train our algorithm in order to model, to have a model to provide prediction of the event, but also we use data in order to analyze them through different use of the data and provide information through a user-friendly visualization in order to give an improved response planning and recommendation to the final user. And we tested these technologies in the pilot years in the 4 regions I talked before. What one of the technologies that we are experimenting in the TEMA solution. That is the digital enabler. The digital enabler is the data technology solution from engineering informatica that transforming data into knowledge through a platform. And now we can go deeply in a technology, how we can manage data, the entire value chain of the data, by exploiting the digital enabler platform provided by engineering. And the platform define a data catalog related to the ecosystem we want to create, use heterogeneous data coming from different data sources, exploring big data and artificial intelligence. Of course, take care of the security and trying to break the silos where their data is now, because one of the most challenges, the most important challenges in the data management is the availability of data. So, for example, in particular, the open data coming from public administration that are in the silos of public administration. And we would like to break these silos in order to make them open. And in engineering's ecosystem platforms allows you to discover, to harmonize, to integrate, visualize all the scattered data in the cities and coming from a multi-source. And the digital enabler represents a single point of knowledge for the cities and for the end user. And this could be used in different domains. For example, smart cities, smart energy, smart agriculture, digital industry, e-health, and so on. This is the technology that we use in the architecture of our solution, but I don't want to go deeply in this specific part. I would like to give you the information about how we are using this component to support the data disaster management value chain. We use the digital enabler, in particular two components of it, the content broker and the storage, the object storage, in order to as a workflow of information. So the content broker provide us a component provided by the Fireware Foundation. It drives the definition of the key open standard that enable the development of interoperable smart solution in an easy way, and provide context data. So we need the data of the context, and the data from the fields, the data from the social network, the data from the sensor, the data from the satellite image is data of the context. And we need also to storage this kind of data. So we use the mechanism of publish and subscribed in order to integrate all the component of the TEMA architecture. What are these components? We have components that collect, analyze data from social media. We have components that collect, analyze data from the sensor in the field, weather station and so on, data from the UAV, so the drones, images and video from the drones, data from satellites. So we have all the data in a certain sense can be publisher of data, but also can be the So provider and the consumer of data, no? What now we say prosumers. And in this case, the content broker provides this mechanism of publish and subscribe. The component that wants to receive data from another component is the subscriber and subscribe to a certain entity in the content broker. The component that wants to publish data in the content broker will be the publisher and create an entity. When an entity is created by a publisher, the subscriber receive this entity. The publisher store also this entity, the data. For example, I'm the component that manages satellite images. I create an entity, say, okay, I created the satellite images now with the timestamp. If there is a component subscribed to use satellite images, the component will be alerted by the context broker, say, okay, there is a new images from satellite, and the images will be stored in the object storage. So the subscriber has all the information in order to take the images from the storage. In the context broker, we store the metadata, so the metadata information, and not the data itself that are stored in the object storage. And it is more or less the architecture. But going to deeply in the context broker and the digital enabler technologies. So the context broker use the NDSIL data format, data model, and provide NGSILD API in order to for the context information management. These are through the fireware architecture. It is possible to manage this data in a standardized way by using a standard API. So we have the application server and the content information, and each kind of this entity can provide specific parameters that can be read and used by all the other components. And the context broker use also this KPI in order to provide access to the data and therefore to the real world data that it contains and represents. This is an example of the context broker in the health domain, no? And for example, the context broker contains the content information that is a set of entities that represent a certain piece of the real world. This is why we can say that these entities are digital twin, a sort of digital twin of objects. So real people of and these digital twins shape realities, allowing us to analyze it and understand it. For example, here we see that the context broker contains the entities represent the world of an hospital. For example, the ambulance with her parameters, the alert with its parameter, the surgery room with its parameter, and so on. And in this case, we can provide a digital twin of the hospital, and each entity represents something belong to the hospital. Each entity is identified with a specific ID. And the next generation service interface, the acronym of NGSI linked data, is an open standard for the context information management, and currently it is adopted in more than 35 smart cities, supporting the NGSI LD, also important enterprises like Red Hat, Atos, Telefonica, and NEC. We have also another standard, the JSON LD, that is used in order to allow the NGSI LD API to exchange data, and this is the data exchange format. And the attribute of a JSON can have different meaning, and for this reason, it was defined an extension to the common JSON we know, in which it is possible to annotate a piece of JSON with additional information. And this JSON attribute become URI so that the meaning is clearer and easier for people and machine to be understood. And the entity type of the NGSI LD provide an entity type that serves as a representation of the entity class or category, and the attributes of an entity represent the characteristic, the parameter, or properties of the entity. As we said, an entity can have more attributes, no? And the attribute of, for example, of the ambulance, in addition to AD, could be, for example, the license plate, location, speed, equipment, and current alert, no? And this is what the attribute of the entity can be. For example, the entity of a car could be the attribute of the entity car could be speed, fuel level, location, and so on. And the NGSI LD API provides the user with the CRUD functionalities, no? The create, read, update, and delete functionality for each entity. And the context broker provide this kind of API in order to create the entity, and multiple entities can be created in a single request, as well as the entity can be updated in a unique way, but also in a wide in a multiple way, as well as an interesting operation that the NGSI LD API provides is the possibility of querying the data, which allow you to make inference on the entity, no? On the specifying condition on the information you want to obtain. Within these query functionalities, the filter are used to customize query and obtain only the desired data. So we can filter all the entity by ID or by type or whatever we want. I would like to go quickly because we are going to finish our time. What is important is that the subscription that are a mechanisms that allow users to receive real-time notification when information associated with the entity meets certain specific condition. So, for example, if we have an entity that states the temperature in a room, and we want to be notified when the temperature overcomes the threshold of 50 degrees, we can put a filter. And when the context broker is updated by a specific components that give the temperature. So, and write in an entity and update the entity with the temperature in the room. The other component that is subscribed to the entity room will receive a notification when the temperature overcome a specific threshold of, for example, 20 degrees. And this is deeply how the subscription request. This is an example of the subscription request. Going very briefly in what kind of storage technology for the storage we use the MinIO, that is a high performance software defined distributed object storage, and it was built from scratch with the private cloud as its target. And the modern data lakes and the data lakehouse are built on modern object storage, and MinIO is one of these that offers a unified storage solution. The MinIO is an Amazon web server AWS S3 compatible object storage that is fully compliant with their API, and this compatibility ensures that application built for Amazon S3 can seamlessly migrate to MinIO. So we have this kind of interoperability that is very important in terms of data integration and data interoperability. MinIO support multiple server-side encryption schema to protect data, talking about privacy and authorization and authentication, and the model data lake need to be not complex, and MinIO is easier to adopt and deploy. And data is constantly getting generated, and that means that it must constantly be integrated. MinIO works also with Kafka, RabbitMQ, and host other solutions. The result is finally a data lake that becomes the single point, the single access point to the data, the single source. Coming to the conclusion. So, big data and storytelling are an evolution of concept already used in the past from other scientists. We talked about Florence Nightingale and the first particle physics. And the final goal of natural disaster management is to improve the life of citizens. The analysis of big data enhance the power to take decision. And please bear in mind from now on that in God we trust, all the others must bring data. Thanks a lot.
I would like to thank the presenter for this presentation. We have any question here in the audience or in the Zoom chat? If we don't have any question, then we can move to the next lecture.